Alright, so the first question, they've given us a graph, a trigonometric graph, which is a sine graph, and they've given us the equation for it. So the equation is given with some unknowns, and we have to basically find those unknowns. So first, let's just go over what each unknown over here represents. So the first thing that we have over here is this P. So the P in this case will be representing amplitude. Then we have R. R represents the baseline. And then we have Q, which represents the period. So the first part says state the value of P. So P is the amplitude. The baseline for this graph that they've drawn over here is going to be this line. This is where around this line we can see that the sine graph is being formed, right? If you're aware of the shape of a sine graph, you'll understand what I'm trying to say over here. So this is our baseline, and what is amplitude? Amplitude is the units, the number of units that the graph goes above the baseline or below the baseline. So if we go above the baseline, the maximum number of units is 3, and below the baseline, the maximum number of units is also 3. So the amplitude will be 3, and the answer for P will be 3. Second part is state the value of Q. Now, Q, as I mentioned, represents the period. If Q is equals to 2, period will be half. If Q equals half, period will, just a minute, period will be double. So firstly the period for a sine graph. So for a sine graph, period is 2 pi or 360 degrees. So period is basically the interval in which it completes one rotation or one cycle. So over here we can see that it's completing one cycle in 4 pi. So that means that the period is doubled. If the period is doubled, Q will be half. So that's why in this case Q will be half. The last part is state the value of R. So R, as I mentioned earlier, is the baseline. The baseline over here you can see is at -2. So the value of R will also be -2. I hope this question makes sense. Let's move forward. The next question we're going to do is this question. So they've given us, if it is given that alpha equals cos inverse 8 upon 17, find without using the trigonometric function or calculator the exact value of this. Now if they've given alpha equals cos inverse 8 upon 17, this can also be written as, if I take the inverse to the left side, I can write this as cos alpha equals to 8 upon 17. Now recall that cos alpha, or cos, is basically the ratio of adjacent upon hypotenuse, right? So in this situation, our adjacent, the value corresponding to adjacent is 8, and the value corresponding to hypotenuse is 17. So I'll use the Pythagoras theorem to find the opposite side. So opposite square plus adjacent square equals to hypotenuse square. So we have opposite square, we don't know, let's say it's a square, plus adjacent is 8, and then hypotenuse is 17. So a square equals 17 square minus 8 square. A equals to cube root of 17 square minus 8 square. So I'll just check what that is. A, or which is the opposite, is equals to 15. Okay, now we have cos alpha already. Let's see what sine alpha will be. So sine alpha is going to be opposite upon hypotenuse, so this will be 15 upon 17, and tan alpha will be opposite upon adjacent, so this will be 15 upon 8. Now what we need to find the value of is 1 upon sine alpha plus 1 upon tan alpha. So 1 upon sine alpha plus 1 upon tan alpha. So we know that sine alpha is 15 upon 17. So 1 upon sine alpha will be 17 upon 15. And for 1 upon tan alpha, that will be 8 upon 15. So adding these up, 15 in the denominator, and we have 25 in the numerator. Divide by 5, we'll have 5 upon 3. I hope this question makes sense. Let's move forward. This is the next question we'll attempt. A curve has equation y equals to 2 plus 3 sine half x for 0 till 4 pi. State the greatest and least value of y. Alright. So let's go over once again what each of these values represents. So we have 2 over here, we have 3 over here, and we have half over here. So this 2 represents the baseline, the 3 represents the amplitude, and then half represents the period. Remember, over here the period, the value is half, so that means period will be doubled. So in A part they're saying state the greatest and least values of y. Now if you think about the sine graph, so it's like this. The least value, the greatest value, let's say, is the number is basically the amplitude is the baseline plus the amplitude. So for a basic sine graph, for sine x, the amplitude is 1 and the baseline is 0. So the greatest value is 0, that is the baseline, plus 1, and the least value is baseline negative 1. So you subtract the amplitude from the baseline. So that's what we'll do over here. For the greatest value, we'll take the baseline and add the amplitude. So we have the baseline as 2 plus the amplitude as 3, so this is 5. And for the least value, we'll take the baseline minus the amplitude. So we have 2, that is the baseline, minus 3, which is the amplitude, so minus 1. So our greatest and least values are 5 and minus 1. Now in part B, they're saying sketch the curve. So first thing that we saw over here was that our period was represented by half, which means that our period is doubled. Now a normal sine graph has a period of, if we have, let's say, sine x, the period is going to be 2 pi or 360. Now if you have sine half x, the period will be doubled. So you'll have either 4 pi or 720. So over here, because we're talking about radians, so our period will be 4 pi. That's the first thing. Second thing is that our baseline is going to be at 2. So and then our maximum value is 5 and minimum is negative 1. So let's label the axes accordingly. So let's get a ruler out. Where's the ruler? There's been an update, I don't know where the ruler is. So let's keep this 0 here. Again, it doesn't really matter that much. You don't have to be very accurate, but just for the sake of it. So we have okay, so we've got our axes labeled. This is 1, 2, 3, 4, 5, and then -1. 0 is marked over there. So the first thing is a sine graph, a normal sine graph. Let's just draw a normal sine graph as well. So I'm drawing the normal sine graph in yellow. So this would start at 0. It would be 1 at pi by 2. It would be 0 at pi. It would be -1 at 3 pi by 2, and then 0 at 2 pi. So this is what a normal sine graph would look something like. And sorry, I'm not that neat, but something like this. Now what's happening is that our baseline is shifted to 2, so our graph will start from here. Then the second thing is that our graph's period has doubled. So instead of having our second point at pi by 2, our second point will be at pi. And this has to be the maximum point, and we just found that our maximum point will be 5. So our maximum point, let's do this in red. Our maximum point will be at 5 and it will be at pi. So I'll go upwards from pi till 5. So somewhere over here we'll have our maximum point. Yeah, let's keep this in crosses. Then the next point is 0 at pi. Again, our period has doubled, so this point has to be at 2 pi, and our baseline is not 0, our baseline is 2. So this point will be at 2 pi comma 2. So somewhere over here. Then our next point on the normal graph, basic graph, is -1 at 3 pi by 2. Our period has doubled, so from 3 pi by 2 it will now be at 3 pi, and this is the minimum point. Our minimum point is going to be at -1, so it's going to be 3 pi comma -1, so somewhere over here. And then the last point, which is this, is at 2 pi in the original graph. Now our period has doubled, so it will go to 4 pi, and it's at the baseline. So our baseline is 2, so it's going to be at 4 pi comma 2. So these are the 5 points that we have to plot. Let's sketch the curve. Again, for sketching, the shape doesn't really matter. It's important that you have marked the correct points. So even if it's like a bit rough, that's fine. It's to just give the shape of the sine graph, and that's enough. Okay, so we're done with this one. Now they're saying in the next part, state the number of solutions of the equation 2 plus 3 sine half x. So if you look closely, 2 plus 3 sine half x is the graph that we've sketched over here in red, equals to 5 minus 2x. So whenever you have a question where you have one side of the equation that you've sketched and then the other side is something else, or it's possible that you can make one side similar to what you've sketched. So what you do is you keep one side as what you've sketched, and then the other side you also sketch onto the graph, and then you look at the number of intersection points of the two graphs, and then that will be the number of solutions of the equation. So what we have to sketch is 5 minus 2x. Let's make a table for this. So for y equals to 5 minus 2x, we have x and y. Let's start with, we just need 2 points because this is a linear equation, so we can plot it with just 2 points. When x is 0, so 5 minus 0 will be 5, and let's say when x is 2 pi, 5 minus 2x will be 5 minus 4 pi, which is -7. Okay, this will be difficult. Let's try pi. This is -1.28. So let's do this in blue. our first point is 0, 5, so that is somewhere here, and the second point is pi, negative 1.28. Let's first draw a line for negative 2. So negative 1.28 will be somewhere over here. Alright, so pi, negative 1.28 will be somewhere here. Let's take out our ruler, join the 2 points that we've drawn in blue, and sketch our line. So this will be the line 5 minus 2x. Alright, now if we look at, so we need to look at the equation of 2 plus 3 sine half x, which is in red. So I'll underline this in red, and then 5 minus 2x, which is in blue. So if we look at these two, there is only one point of intersection, which is I've circled in green. Let's highlight this. In fact, let's highlight this in green. This is the point of intersection. There is one point of intersection. That means that there will be only one solution. So you can write one solution. Okay, we're done with this question. Now next question, question 49 over here. By first expanding cos theta plus sine theta whole square, find the three solutions of the equation cos theta plus sine theta whole square equals 1. Alright, so it's cos theta plus sine theta whole square, so that's similar to the identity a plus b whole square equals to a square plus 2ab plus b square. So if I expand cos theta plus sine theta whole square using this identity, I'll have cos square theta plus 2 cos theta sine theta plus sine square theta. Yeah, and then what we have to solve is, we have to solve cos theta plus sine square theta equals to cos theta plus sine theta whole square equals 1. So we can equate this whole thing with 1. So we have cos square theta plus 2 cos theta sine theta plus sine square theta equals 1. Now if we look at the formula list, there's this formula, there's this equation cos theta identity, cos square theta plus sine square theta equals 1. So if we take the cos square theta over here and the sine square theta, we can add these to get 1. So we have 1 plus 2 cos theta sine theta equals 1. So we have 1 and 1, we can equate those two. So we'll have we can cancel these two out. We'll have 2 cos theta sine theta equals 0. So in such cases, it's possible that either cos theta is 0 or it's possible that sine theta is 0. In both cases, we would get the equation as 0. So we'll say that cos theta can be equal to 0 or sine theta can be equal to 0. Now think of the graphs of cos theta and sine theta. When are those graphs equal to 0? The graph of sine theta is like this. It's 0 at 0, it's 0 at pi, and it's 0 at 2 pi. So the range given is 0 till pi, so we'll only look till there. So the points that we can see over here at which sine theta is 0, let's draw this graph. So it says, so we have our graph like this. From 0 till pi, the graph is only like this. This is 0, this is pi by 2, and this is pi. So from here we can see that sine theta is 0 at theta equals 0 and at theta equals pi. For cos theta, let's do something similar. So the cos theta graph is starts at 1. So if we draw pi by 2, this is 0. So it starts at 1, then it goes to 0, and then it goes to negative 1. So it's something like this, right? Or in fact, try to draw it a bit better. Something like this. So we can see that it's 0 at pi by 2. So theta equals pi by 2 is when cos theta is 0. So they had asked us find the three solutions. We found the three solutions, which are theta equals pi by 2, theta equals 0, and theta equals pi. Hence verify that the only solutions of the equation cos theta plus sin theta equals 1 for 0 till pi are 0 and half pi. Okay, so let's verify the only solution of the equation. So for the equation cos theta plus sin theta whole square equals to 1, we got the solutions 0, pi by 2, and pi. Now we need to look at the equation cos theta plus sin theta equals 1. Alright, let's just verify. So if we work on this equation that we had in the first part, we can shift the square root to the right and we'll get cos theta plus sin theta equals square root of 1, and we'll have a positive negative. So we basically have positive 1 and negative 1. So we have cos theta plus sin theta equals positive 1, and we have cos theta plus sin theta equals negative 1. So the solutions for the above equation are 3. Now some of these will apply to this part of the equation and some of these will apply to this part of the equation. So we need to confirm how many of them apply to this part of the equation. So let's see if 0 applies to this. So if we had, for example, if we consider theta equals 0, let's do it on a new line. So we would have cos 0 plus sin 0. Cos 0 is 1 and sin 0 is 0, so we get 1. So we can say that this is correct. Then we try theta equals to pi by 2. So we have cos pi by 2 plus sin pi by 2 equals, so cos pi by 2 is 0 and sin pi by 2 is 1, so we can again say that this is equal to 1. So this is also correct. Now the last possible is theta equals pi. So if we have cos pi plus sin pi, cos pi is going to be negative 1 and sin pi would be 0. So this will be equal to negative 1, which is not correct. So we've shown that hence only 0 and pi by 2 are solutions to cos theta plus sin theta equals 1. I hope this made sense. Let's move. Okay, there's another part. Prove the identity sin theta upon cos theta plus sin theta plus 1 minus cos theta upon cos theta minus sin theta equals to the right hand side. So we'll start with the left hand side. So the first thing that we can do is we can merge the two fractions that we have on the left hand side. So let's have cos theta plus sin theta and cos theta minus sin theta. So for the left fraction, we'll multiply it with the denominator of the right fraction. So we have sin theta times cos theta minus sin theta, and vice versa for the right fraction. So 1 minus cos theta multiplied with the denominator of the left fraction. Okay. Now keep in mind the identity a plus b, a minus b equals to a square minus b square. We can apply this in the denominator. So our denominator will become cos square theta minus sine square theta. Alright, now for the numerator, let's open this up. So we have sine theta cos theta minus sine square theta plus cos theta plus sine theta minus cos square theta minus sine theta cos theta. Okay, now if you look closely, we can cancel out sine theta cos theta with sine theta cos negative sine theta cos theta, and then we have so if we take negative common from sine square theta and negative cos square theta, so we'll have negative sine square theta plus cos square theta, and then we have cos theta plus sine theta. And the denominator, if we look at what they've asked for on the right hand side, that's 1 minus sine square theta. So there is no cos theta in the denominator. So let's try to eliminate cos theta from there. So we have the identity cos square theta plus sine square theta equals 1, which we'll also use. But we can shift this around and make this cos square theta equals to 1 minus sine square theta. So to remove the cos square theta from here, we'll use this new identity that we just made. So we'll replace cos square theta with 1 minus sine square theta minus sine square theta. In the numerator, we have sine square theta plus cos square theta. We can use this identity there. So that will become 1. So we have negative 1 plus cos theta plus sine theta upon 1 minus 2 sine square theta. And this is equal to the right hand side. So we have proven this. All right. In the last part, they're saying using the results of A2 and B, solve the equation. This is given. So first thing over here in such questions, always you'll see that one side of the equation will be similar to what you've used in proving the identity. So we can replace this whole thing with this simplified form. So first let's do that. So we have cos theta plus sine theta minus 1 upon 1 minus 2 sine square theta equals to 2 cos theta plus sine theta minus 1. Alright. So they're saying using the results of A2 and B. Can we simplify this? Okay, so we can simplify this as well. Will it be the right thing to do though? So if we look at these two sides of the equation, we have cos theta plus sine theta minus 1 over here and cos theta plus sine theta minus 1 on the right side as well. We could cancel these two out and we'll be left with 1 upon 1 minus 2 sine square theta equals 2. I can shift this to the right side, so this will become 1 equals to 2 1 minus 2 sine square theta, which is same as 1 equals to 2 minus 4 sine square theta. And we can shift this around a bit, so we'll have 4 sine square theta on the left and we have 2 minus 1 on the right, so that will become 1. Then we can write sine square theta equals to 1 upon 4. Okay, so if we have sine square theta equals to 1 upon 4, we can write this as sine theta equals to plus minus root of 1 upon 4, which is the same as plus minus half. So we've got sine theta equals to plus minus half. So we have sine theta equals to half and we have sine theta equals to negative half. Let's just leave it as plus minus half. So the first thing we need to do is we need to find the basic angle. For the basic angle, we'll just take sine inverse. We ignore the sign of the ratio when we're taking the basic angle, so we'll just take half. Sine inverse half in radians will be pi by 6. Alright, now it's given over here that it's positive or negative. So sine is positive in the first and second quadrant, negative in the third and fourth quadrant, so we'll consider all quadrants over here. However, the limitation that will apply over here is that they've given that the range is from 0 till pi, so we can only take the first and second quadrant. Alright, so we have pi by 6. Now in the first quadrant, theta should be equal to alpha, so theta will be equal to pi by 6. And in the second quadrant, we have theta equals to pi minus alpha, so pi minus pi by 6, which will be equal to 5 pi by 6. So these are two of the values that we have gotten. Now what's important to note over here is that over here we cancelled out these two brackets. Now it's also possible that if these two are both equal to 0, so if for example this is equal to 0 or this is equal to 0, which is the same thing, then we'll also have the equation equal to both sides, right? So one possibility that we did was that if we cancel these out, we have the equation equal and then we solve that further on. But if this was equal to 0, then this would also be equal to 0, so we would basically just have 0 equals 0 and this equals to sign would have worked. So we also have to consider that possibility. In that possibility, if we're considering cos theta plus sine theta minus 1 equals to 0, so we basically have cos theta plus sine theta equals to 1. This is where this statement comes into play using the results of part A2. So in part A2, we got the solutions of this equation cos theta plus sine theta equals to 1 for the same range 0 till pi. So the answers to that were 0 and pi upon 2. So the solutions for this equation are 0 and pi upon 2, which will also be two of the answers for this question for us. So our complete set of answers will be 0, pi by 6, pi by 2 and 5 pi by 6. So once again, why we're doing this? So first, when we got this equation, we simplified this by cancelling these two out, and that's how we got two of the solutions. However, the biggest hint is that they've said that you have to use part A2, so you have to think about how you can use part A2. Now if you look at this equation, you think about it, it's also possible that this is equal to 0, in which case this would also be equal to 0 and the equation would still be valid. So that is the situation that we'll have to also apply so that we can use the results of part A2, which we did over here, and get two more solutions. Alright, next question, question 52. So we have find the exact solution of the equation tan inverse 1 upon 6 pi tan inverse 4x equals to negative cos inverse half root 3. Alright, so they haven't said anything that we can't use our calculator over here, as they did in a previous question that we did, which was this one. So that said without using the trigonometric function or calculator. So over here we'll assume that we can use it because they haven't specified anything. So first thing we'll do is pi upon 6 we'll leave as it is. Tan inverse 4 upon x, tan inverse 4x also we'll leave as it is. For negative cos inverse half root 3, we'll find the value. So cos inverse root 3 upon 2 is equals to pi by 6. So this is equal to negative pi by 6. If we shift the left pi by 6 to right, we'll have tan inverse 4x equals to negative pi by 6, negative pi by 6. So tan inverse 4x equals to negative pi by 3. All right, so we have 4x equals to tan negative pi by 3. What will tan negative pi by 3 be? So tan negative pi by 3 will be negative root 3. So we have 4x equals to negative root 3. So x equals to negative root 3 upon 4. I hope this is clear. All right. 53. Do we have more questions after this? Yeah, 2 more questions. So 53 is saying verify the identity 2x minus 1 4x squared plus 2x minus 1 equals to this. So we'll just multiply these two brackets. So we have 2x multiplied to all 3 terms. That will be 2 4s are 8x cubed plus 4x squared minus 2x minus 4x squared minus 2x plus 1. So 8x cubed as it is, 4x squared and 4x squared cancelled out, negative 4x plus 1. So we can say that we have verified as it's equal to the right hand side. Now they've said prove the identity tan square theta plus 1 upon tan square theta minus 1 equals to this. So whenever you see proving identity questions in which there is, let's say, tan on one side and then there's sine or cos or one of those on the other side, remember that you always have to convert tan to sine and cos. So to convert, so firstly let's write this as tan square theta plus 1 divided by tan square theta minus 1, and we can convert this to a fraction form, or why am I doing this? You can just write this as tan square theta plus 1 times, let's just do this, divided by tan square theta minus 1. Now remember that tan theta is equals to sine theta upon cos theta. So tan theta we can replace with tan square theta we can replace with sine square theta upon cos square theta plus 1 divided by sine square theta upon cos square theta minus 1. Now let's combine these two into one fraction. So we'll have cos square theta as the denominator and we'll have sine square theta plus cos square theta in the numerator, divided by, this is a division, we have one fraction, so cos square theta in the denominator, and in the numerator we'll have sine square theta minus cos square theta. Okay, so if we want to convert this division to multiplication, we'll have to reciprocate the fraction after the sign. So sine square theta plus cos square theta will become 1 because we have the identity sine square theta plus cos square theta equals 1. So sine, that becomes 1 upon cos square theta, and then if you want to convert this to multiplication, we'll have to reciprocate the next fraction. So this will become cos square theta upon sine square theta minus cos square theta. So we can cancel these two out and we have 1 upon sine square theta minus cos square theta. Now from this identity we can make this into sine square theta equals to 1 minus cos square theta. So we have 1 upon, we can replace sine square theta with 1 minus cos square theta, and then we're left with 1 upon 1 minus 2 cos square theta. So proved. Okay, now in the next part, just a minute. So we have, using the results of A and B, again we have to use the results of both the previous parts. Solve the equation tan square theta plus 1 upon tan square theta minus 1. So first thing, that's the same as this, so we can replace tan square theta plus 1 upon tan square theta minus 1 with 1 upon 1 minus 2 cos square theta. So we'll write this as 1 upon 1 minus 2 cos square theta equals 4 cos theta. Now if we cross multiply, we'll get 4 cos theta minus 8 cos cube theta. Shifting everything to the right side, so I have 8 cos cube theta minus 4 cos theta plus 1 equals 0. Now if we look at part A, so we know that 8x cube minus 4x plus 1. Let's take this to the next page. So we have this identity, we've proven this already, so we can use this directly. So if 8x cube minus 4x plus 1 is equals to this, so 8 cos cube minus 4 cos theta plus 1 will also be equal to this same two brackets just with cos. So we can write this as 2 cos theta minus 1 bracket 4 cos square theta plus 2 cos theta minus 1, and this is equal to 0. So we've used both A and B. Now we just need to solve this. So if it's saying that this multiplied with this is equals to 0, so it's possible that this bracket is 0. If this bracket is 0, then we'll get the output as 0, and if this bracket is 0, we'll get the output as 0. So both of them can be equal to 0. So we have 2 cos theta minus 1 equals to 0, or 4 cos square theta minus 2 cos theta minus 1 equal to 0. This just becomes cos theta equals to half. Over here, can we do middle term breaking? 4 2 2s are 4. I don't think we can do middle term breaking over here. Let's apply the quadratic formula. So cos theta will be equals to minus b, will become minus and minus positive 2, plus minus root of b square. So 2 square is 4 minus 4ac upon 2a. So we have cos theta equals 0.809. Sorry, my bad. So this is going to be plus 2. So you can see over here it's plus 2. I wrote minus by mistake. So this will become minus 2. So our cos theta will be equal to negative 1 plus root 5 upon 4, or second answer is negative 1 minus root 5 upon 4. Alright, and also let's look at what these are equal to. So this one is equal to 0.309. The next one is equal to negative 0.809. Alright, calculator is working very bad right now. Yeah, so we have 3 equations of cos, and our range is given as 0 till 180. So remember that your calculator should be in degree mode because it's degrees given as the angles over here. So let's first solve cos theta equals to half. The basic angle will be cos inverse half, which is equals to 60 degrees. Over here it's positive, so cos is positive in the first and fourth quadrant. Fourth quadrant is not applicable over here because that's outside the given domain of theta, so we'll only go with the first quadrant. So in the first quadrant, theta will be equal to alpha, so it will be equal to 60 degrees. So that's our first answer. Now For the next one, we have cos theta equals to 0.309, or this whole thing. So we'll do, for alpha, we'll have cos inverse of 0.309, which is equal to so we have cos inverse 0.309, 72 degrees. Again, this is positive, so we'll only take the first quadrant, and we'll have theta equals to alpha, which is 72 degrees. For the last one, we have alpha equals to cos inverse negative 0.809. So for alpha, we don't take negative, we'll just take 0.809, and our alpha value is coming 36.0 degrees. This is also 72.0 degrees. So now over here we have the value as negative 0.809, so that means that cos is negative. So cos is negative in the second and third quadrants, but in our domain of 0 till 180, only the second quadrant comes. So we'll take the second quadrant for this case. So in the second quadrant, theta is equals to 180 minus alpha. So theta is equals to 144 degrees. The values of theta are 60 degrees, 72.0 degrees, 144.0 degrees. These are the three answers over here. I hope that's clear. Moving on to the last question, 54. So we have 5 cos theta minus sin theta tan theta plus 1 equals 0 may be expressed in the form this. Show that the equation can be expressed in this form. Alright. So we need to express this equation into something that only has cos. So we'll convert tan to sin and cos. So we have 5 cos theta minus sin theta. Tan theta can be written as sin theta upon cos theta plus 1 equals to 0. So we get 5 cos theta minus sin square theta upon cos theta plus 1 equals 0. Now remember, whenever you have sin square, you need to convert it to cos because our required equation only has cos. So we'll use sin square theta equals to 1 minus cos square theta. So 5 cos theta. We could also do this, that we shift sin square theta upon cos square theta over here, 1 cos theta over here. So 5 cos theta plus 1. Sin square theta will replace with 1 minus cos square theta upon cos theta. Now we can cross multiply this to the left side. This will become 5 cos square theta plus cos theta, shifting 1 minus cos square theta to the left side, so negative 1 plus cos square theta equals to 0. So we get 6 cos square theta plus cos theta minus 1 equals to 0. So we've got our equation in this form, and our value for A is 6, B is 1, and C is negative 1 shown. Now they're saying, hence solve the equation 5 cos theta minus sin theta tan theta plus 1, which is this equation, for 0 till 2 pi. Now we know that this equation is exactly same as this equation, so we can just solve this equation instead of the first one. So we'll be solving 6 cos square theta plus cos theta minus 1 equals to 0. We can middle term break over here, so we'll get plus 3 cos theta minus 2 cos theta minus 1 equals to 0. If we take 3 cos theta common, we'll have 2 cos theta plus 1, and then taking negative 1 common, we'll have 2 cos theta plus 1 equals to 0. Taking 2 cos theta plus 1 common, we'll have 3 cos theta minus 1 equals to 0. So either of these brackets can be equal to 0. So we have 2 cos theta plus 1 equals to 0, or 3 cos theta minus 1 equal to 0. So 2 cos theta plus 1 equals to 0 is basically cos theta equals to negative 1 upon half, and this is cos theta equals to 1 upon 3. So let's find alpha for both of them. Cos inverse of, we'll only take half because for alpha we just use the magnitude. So cos inverse half is 60 degrees. We have to do in radians, so make sure your calculator is in radians because the domain is given in pi. So this will be pi upon 3. For the other one, alpha will be cos inverse 1 upon 3, which will be equal to 1.23. So for the first one, this has cos as negative, which is in the second quadrant and third quadrant. This has cos as positive, which is in the first quadrant and the fourth quadrant. So we have second quadrant, theta will be pi minus alpha, and third quadrant, theta will be pi plus alpha. So we have 2 pi by 3, and we have 4 pi by 3. Over here, first quadrant, theta will be equal to alpha, and fourth quadrant, theta will be 2 pi minus alpha. Let's see what that is, which is 5.05. So our answers will be 1.23 and 2 pi. 1.23, 2 pi upon 3, 4 pi upon 3, and 5.05. So that's it for this video. I hope these questions made sense. If there's any confusion, you can comment below, and I'll try my best to sort that out. Thank you.